All right, guys, for chapter 12, we're talking about alkanes, which means all the carbons are singly bound to each other. So, alkanes, here you go. They're compounds with only carbon and hydrogen, with only single bonds between carbon atoms. Uh, so, compounds in which the carbons are all lined up, those are simple, or linear. So, propane, octane, pentane, heptane, those things. Cyclic alkanes are when the atoms are arranged in a ring. So, we can talk about cyclohexane, cyclopropane, cyclooctane, something like that. Now, in order to get a cyclic compound, you have to have four or more carbons. So you can't have like a little triangle with three carbons attached to each other. It just doesn't work. Then there's branched alkanes, which are very, very common. Carbon atoms may be attached to more than two other carbon atoms, so like isopentane or neopentane, something like that. You'll see where we're going with this. And all of these play a role in biochemistry, and it's all about how things are connected. That's how we're going to view this. Constitutional isomers, this will test your imagination. Not crazy, but uh, isomers are different connections between atoms. The ratios are the same. So I put dimethyl ether right here, right? And this is ethanol. Here we have pentanol, isopropyl alcohol, and ethyl methyl ether. Say, how are they similar? Well, here in our first little group, they both have two carbons, they both have six hydrogens, and they both have one oxygen. So they have the same number of atoms. So these are constitutional isomers. There's different connectivity. Here, same. Three carbons in all of them. We have eight hydrogens in all of them. I think, yeah, eight hydrogens in all of them. But the only difference here is how everything is connected. So that's what we have. That's what makes constitutional isomers different. Bond rotation. So groups can rotate around single bonds, only single bonds. That's where you get rotation. And so here I have 1, 2, 3, 4, 6. I have 6 carbons. So we have hexane. And what I try to do here is show you that there's a rotation around this bond. So there's 1, 2, it's the third bond. And as there's a rotation around that, these two carbons swing around the back. And so it looks a little different, but everything's still connected the same. The more single bonds, the more rotation. So in octane, you get more rotations. These rotations allow different octane molecules to like turn and hook onto each other. So what you find with alkanes is as there's more carbons, the boiling point goes up because they're able to stick closer together. And then here, this is, I did this one, it's this compound right here. The rotation is only on single bonds. So these double bonds within that six-membered ring, there can't be any rotation. So that hexagon is sort of locked into place. There can't be any twisting or bending within that.